In the early days of computing, delivering a software update required an industrial process that could take months to execute. Programmers had to encode their work into physical pieces of paper, with holes literally punched into the cards, fed into massive mainframe machines. Even as the industry moved away from paper and onto compact disks and floppy disks, distributing software still meant writing data to a physical object and shipping it through the postal service. Because updates required sending a physical device through the mail, time between patches remained slow. If a bug made it onto that disk, the cost and effort required to ship a fix was a massive burden on the company. The dot-com boom of the 2000s removed the physical barrier. Companies could deliver web applications directly to users over the internet, shrinking the turnaround time for updates from months to minutes. But that speed introduced a new risk. If an engineer pushed flawed code to a live server, millions of users would experience that failure instantly. Developers needed a way to automatically test every code change before it reached production. This concept became known as continuous integration, or CI. One of the earliest examples of this emerged in 1997 at Netscape. They built a tool called Tinderbox, which watched their version control system and attempted to build the software with each new commit. By 2005, a developer at Sun Microsystems introduced a project called Hudson, which provided a large ecosystem of plugins to handle various testing use cases. Hudson was eventually forked and evolved into Jenkins, a platform that became the dominant choice for the continuous integration landscape. However, operating Jenkins came with a high maintenance overhead. Teams had to keep hundreds of plugins secure and author their pipelines in Groovy, a language rarely used outside of Jenkins itself. Automated testing was now mandatory for a software team to survive, yet the tools required to do it were fragmented and lived on servers completely separate from where the actual code was stored. By 2018, the CI market was saturated. Massive cloud hyperscalers like AWS and Google had their own pipeline tools, while legacy platforms like Jenkins held a firm grip on the enterprise space. When GitHub released GitHub Actions that same year, they appeared to be a late entrant in a market with very little room for a new player. To compete, GitHub leaned into frictionless proximity. They built their automation engine exactly where the developers were already working. Teams no longer had to set up external servers to configure their pipelines. They could bootstrap an entire CI system by dropping a simple YAML file directly into their existing repository. Then they leveraged their open-source community to build a public marketplace. Instead of writing custom logic for every pipeline step, developers could pull down pre-built actions for almost any task imaginable. By combining where code lived with plug-and-play modules, GitHub turned the complex chore of continuous integration into an exercise in modular assembly. This chart shows pipeline usage data from the Cloud Native Computing Foundation. Among developers adopting modern cloud-native architecture, GitHub Actions has overtaken Jenkins as the most popular option. Jenkins maintains its position primarily in established enterprise environments, where complex, long-running setups already exist, and the cost to migrate is high. If we look at GitHub's closest version control rival, GitLab, the difference in ecosystem scale is clear. While GitHub boasts thousands of third-party actions, GitLab's marketplace contains fewer than 500 total options. GitLab provides powerful out-of-the-box features, but because you must use their platform to access those tools, that approach naturally restricts the size of the community building for it. There are also standalone cloud providers like CircleCI, which offer useful features that GitHub lacks natively, such as the ability to instantly retry a failed job with an active SSH session. Despite competitors offering specific technical advantages, the extra setup required to connect a standalone tool to a codebase pushed the majority of users toward GitHub's path of least resistance. Out of the box, GitHub Actions does not have the fastest execution times, the most powerful runner configurations, or the best native observability metrics. In fact, an entire industry of third-party infrastructure companies, like Namespace, exists specifically to replace GitHub's default runners with faster compute and better caching. But raw technical benchmarks weren't the deciding factor. GitHub won by prioritizing the developer experience above all else. The evolution of software delivery reflects a shift toward absolute invisibility. We began with physical punch cards loaded by hand, and eventually condensed that labor down into a single text file sitting in a repository. The ultimate market winner in continuous integration is simply the tool that makes the complexity disappear, turning the discipline of DevOps into just another line of code.